Welcome to this Business Central launch event about what's new in ALGO for GitHub on build and performance. My name is Freddy Christiansen, Technical Evangelist with Microsoft, and together with me I have
Alexander. I work with Freddy on ALGO for GitHub, and I'm part of the engineering systems team at Microsoft.
So, in ALGO for GitHub, in this release, we have quite a few things like on build and performance. So, and we'll go through these not in detail, but just on the surface and try to explain to you what these things are good for and how they can help you in your DevOps solution. The first one is incremental builds, and let's have a look at what that actually is. So, incremental builds is all about only building what's needed. So if you're modifying, if you have a repository with 10 apps or 10 projects, you'll only build the apps that are actually modified in the commit that you're running right now. Default, if we go back in time, this has always been enabled for pull requests, but it has never been enabled for a CI/CD. The primary reason for that was that we wanted every CI/CD build to have a complete set of artifacts built. And we've solved that. So we're saving time on continuous integration when only building what's needed, but we're also saving time on deploying because the unbuilt apps will obviously not be deployed. They'll figure out that these apps are already deployed. Let's have a quick demo of what this actually contains. If we have a look at the build here, there's a lot of different commits here, but I'll just have a look at this commit and click this one and have a look at this build. Total duration 24 minutes. Looking at the first build here, these builds are 24 seconds. Obviously that's not a complete build, but here we have normal build time for when doing a normal build using GitHub runners. It's approximately 15 minutes per app. So what's happening here is that the only apps here that have been rebuilt is the Danish one and the Italian one, and actually with different build modes as well. But looking at that, the artifacts for the build is complete. We'll both have the common, we'll have the Italian one, we'll have the Danish one, we'll have the W1 app. So all the artifacts are there, but if we look at what's inside these artifacts, the W1 one will actually be the artifacts from the previous build. And the Danish one will be the artifact from this build. Looking at the summary, we'll be able to see that the artifacts that are not built is taken from the last known good build, which is this one, should then be build number 22 somewhere, I guess, whatever. Yep. Build number 22 up here. So the artifacts that were not built is copied from the last known good build, meaning that the build that we are using and running with will be complete. Back to the presentation. Let's have a look at the next thing, which also kind of works together with incremental builds quite a bit, workflow concurrency. Now, what you can do with workflow concurrency is to control workflow concurrency. Wow, kind of says itself. It works very well with incremental builds. If you set up incremental builds on a branch or on a repository, then the workflow concurrency can ensure that if you are doing 2 commits after each other, it's going to cancel the prior build and just build the next one. And because of incremental builds will look at the last known good build and the changes since the last known good build. It will find all the changes between the last known good build and what we're building right now. Let's have a look at that. The last known good build we had was build number 22. That's this one. After that, we did a commit here, which was cancelled. And the reason for that was obviously that we did another commit seconds later, which is 24. Let's look at what actually was changed in 23. What we did here was we made a change to the Italian version. If we then go back and have a look at the change we did in the 24, that was one change in the Danish version. And as we saw earlier, the build made in 24 here actually builds both the Italian one and the Danish one because both of those changed since the last known good build. So this way, having workflow concurrency set together with incremental build will save you quite a bit of time. Let's look at the settings just to see what actually is necessary in ALGO settings here. And let me see here, the conditional settings here for workflow concurrency is here. And the incremental builds are set here to run on push and on pull requests, but not on schedule. With that, let's go back to the presentation, and I'll give the word to Alexander to talk about conditional setting based on build modes.
So taking a step back first, let's just talk about what build modes are. So in this settings file here, you can see I've defined a default build mode and a next major build mode. This basically allows me to build the project in two different configurations, default and next major. But ALGO doesn't really, out of the box, do much different for these two build modes. So in the past, what you've been able to do is you could add a script override, for example. You could say, if default mode, then do this. If next major mode, then do that. But with the latest version of ALGO, now we also support conditional settings based on build modes. So when you build your CI/CD, you'll get these build common in default and next major mode. And now with conditional settings, you can then specify that in your next major build mode, for example, it might make sense that you want to grab the next major artifact rather than the 25.4 artifact. And so ALGO will grab the conditional setting here when we're building in next major mode, and we'll grab the next major artifact instead of the 25.4 artifact. Next up is preprocessor symbols. So again, AL lets you add these preprocessor symbols to your code. Like in this case, we can add this global tag to our code. And that means when we build this app, when we specify the global preprocessor directive, then we'll include this code. Otherwise, we won't. And now ALGO also supports adding preprocessor symbols as a setting. So you can add this preprocessor symbol setting, which is an array, and then you just give however many of these preprocessor symbols that you're using in your code. So in this case, we're telling our ALGO project, please build using this global symbol. So when we compile the app, we pass this global symbol to the compiler, and then it gets used. If we go back to the previous example around conditional settings, you can also apply preprocessor symbols in this situation as well. So you could imagine that your AL project has some different logic based on whether you're building the default version or on the next major version. And so in your conditional settings, you can just add the preprocessor symbols that you need. So in this case, just add the next major preprocessor symbol if that's what you're using. And ALGO will build using the next major preprocessor symbols in the next major build mode. And in the default mode, it won't use these preprocessor symbols.
So, next topic is no more this build artifacts. So, in the old days, or up until this version, you would see artifacts like this, where you have like a project, the apps, and build output, and maybe test result and stuff like that. And then you'd have like this build, and then a project name, and then apps, or this build, and then a project name, and then test apps. They were used for building multi-project builds, where one project had dependencies on the other project. So we kind of had to create an artifact, an artificial artifact that the other project could use, and the retention period for that one was 1 day. Now, in this new version, we actually create full artifacts in all builds. We do create them as short-lived artifacts, meaning that you can use a setting to define that these short-lived artifacts can be more than a day. Right now they are 1 day. But we are just using these normal artifacts for the resulting, for the project that we're building afterwards. Now it's hard to demo that something is gone, so I don't have a demo on this, but if you like stumble over that normally you had these artifacts, you don't have them anymore. That is because we now always create full artifacts that are short-lived, and you can create a setting for that. There's a new versioning strategy in the latest version of ALGO, versioning strategy 3. We had some partners talk about why is only major minor defined by app.json when you demand a release to have 3 digits? Well, it actually makes sense to have a versioning strategy where 3 digits are controlled by app.json and only 1 digit controlled by GitHub, which is the 4th digit. So using versioning strategy 3, you will have major, minor, and build controlled by app.json. And then when you release, you will know exactly this is the version that I want to release, and you can specify that in your release, and the 4th digit will be the counter to run that. With that, over to Alexander.
Yes, and the final topic for this session here is commit options. So again, taking a step back, certain ALGO workflows can create pull requests or do direct commits into your repository. Example of such could be update ALGO system files or increment version number. And a piece of feedback that we got from partners was that you want to be able to inject some kind of message into the commit message or into the pull request. And so in the latest versions of ALGO, we now allow that. So what you'll do is you'll add this commit options construct. And within here, you have 3 options. You can specify a message suffix. So this gets added to the end of your commit message or at the end of your pull request. If you are creating pull requests, then you can also specify if they should be auto-merged. And finally, we allow adding pull request labels. So with that, let me go into a demo. So we're here in the Microsoft BC Apps repository. This is where the system application and the business foundation lives. And in here, we use ALGO, and we're also using commit options. So if we go into the .github folder and under ALGO settings, scroll all the way down, you can see we're using this commit options construct. Now, the reason we use this related to AB hashtag and then an ID is because we use the Azure Boards integration. This is an app that we've installed in our repository where when you specify AB hashtag and a number, then we link that pull request to a work item in Azure DevOps. This is how we kind of get a better integration between GitHub and Azure DevOps. And similar kinds of integrations exist for other work item management tools. So with these commit options set, if we go to an example of a pull request. So this was last time we updated ALGO system files. As you can see, we're updating ALGO system files here. You get all the release notes. And then as specified, we get this automation label applied. We scroll all the way down. We get this related to suffix that has a link to Azure DevOps. So if you click here, it will take you to our Azure DevOps project. We can see the work item and so on. And finally, it sets the auto-merge option automatically. So all I have to do as a maintainer is just to look through the files, look through the release notes, and then approve, and then it gets merged into our repository.
So with that, thanks for watching the video.
Thank you.